So now we're ready to talk in general about the problem of shape from shading. So the basic problem is this. Given, say, one, maybe more, but for now one image that looks like either this top image or the bottom image, can you, the computer, recover for me a function z of xy? So that's why it's going to map onto this gradient space nicely. So we're imagining that we've just got a single viewpoint. You can think of z as coming towards me, and I want to know the height of the function as I go over the image. By the way, this is just one representation of depth. It's a very viewpoint-specific representation of depth. If I had multiple cameras and I had different viewpoints, then the notion of z as a function of xy would not be a great representation of the geometry that's out there. And in fact, much later in the class, we'll talk about other depth sensors and things like point clouds, which is a different way of representing geometry. But for here, we're just talking about z as a function of xy. So the fundamental question is, given this single image, can we recover the 3D shape? Well, as we talked about when we did lightness, fundamentally this is an ill-posed problem, right? Because I don't know what the underlying albedo is, and I don't maybe not know what the illumination is. So there could be lots of different shapes and combinations of illumination, albedo, that would give the same image. So, as I said, this is ill-posed. In order to solve this, we have to make some form of assumptions. And those assumptions can be the lighting is known, so I know the direction of the light. Maybe I'm assuming that it's Lambertian and that it's the same albedo everywhere. That would be an example. Or maybe I say that I know what the boundary conditions are. What we're going to have to do is we're going to have to bring in some other kinds of assumptions to make this work.